had some interesting answers, but the one that repeated itself a couple times was x is 1 and y is 5. So first of all, here's my equations. Any questions about that? Add 21 to both sides, solve for y on this one, double check your work. When I graphed them, here's what I got. If my my computer will work, but it does not want to work. Here's what my graph looked like. Is that how yours looked? That's how it should look. Analyze, right? Intersection. So if you said 1, 5, I agree. That's one of the intersections. But notice what I said. That's one of the intersections. Can you see the impending intersection down here? So it's always good to either zoom out or zoom fit. Zoom fit usually will put everything you need right into the picture. So there it is. There's the other intersection right there. And you know on the ACT and on your end of course test, one of the answer choices will be the 0.15 all by itself. But the correct answer choice is both of these two intersections. So you should have said 1, 5, as well as, what is that, -9, -15? -9, -15. So if you didn't get this right, it's not, you shouldn't be depressed. The point that of this problem is to realize you have to zoom out or zoom fit to find all the intersections. Questions on one? Okay. Number 2, or I guess the EOC review, we've got a lot of stuff in this one problem. So first, there's my graph. I've already filled out a couple things. Yes, it's a function by the vertical line test. The domain is all the numbers to the right of 1, so I think it starts at 1 and goes to the right. Or if you want to say it's coming in and it stops at 1, I guess that's fine too. Is it getting bigger? Is it getting higher or lower? It's definitely going down. Okay. So y is less than or equal to 5. Notice 1 and 5 are both right there in the equation. Remember, this is backwards, x minus 1, so you would think left 1, but it's actually right 1. Plus 5 is kind of the logical one, it makes sense. Did you find the 0? Does it or doesn't? How'd you get 26? Okay, so then you did the drag. Uh-oh, it's getting close. Ah. Good. That's a great way to do it. Press once, highlight it, and there it is. 0.260. Any other ways you could have found those coordinates? I can think of one other way. Yep, you could have traced. Could have traced. All right, last but not least, the inverse. Now let's go rapid fire here. Tony, what's first? Bingo. It's an ugly negative sign. Tia. Good. All right, hold on. Can we go college style today? Okay, Cachette. Good question. What did I forget to switch? Thank you. She's like, what's going on? Okay.
The opposite of the minus.
Okay. How do you want to do that?
Add, like add both sides. No, you make it opposite.
Okay, so tell me what's right.
Turn x to x plus 5.
I agree, +5. What about x?
Negative.
There you go. And then now over here, I think we confused some people, so let's back up just one step. Put this in here. What did we do to both sides there? But technically we divided everything by -1. So the negatives cancel. Okay. Everybody good now? Lorian? Okay. How do you feel about my college solving, by the way? It's kind of nice, isn't it? It saves you a lot of writing. Keep on what's last. Good. F inverse of x I'm gonna keep challenging you to solve your equations more and more like this. You're gonna listen. Your pencil will last twice as long if you solve your equations like this, because you don't have to write down all those in between steps. So, in the end, I'm trying to save you money. Long and complex warm up. This is all these are all hard ACT questions. These are upper level. Find the inverse of that. Ooh. And then completely tell me everything about this function. You got to know functions inside and out. And we will keep reviewing until you are perfect at it. Take your warm up, set aside, look at today's notes. And 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Sketch the following two graphs in the space provided to the right. So let's review. This is really an Algebra 1 skill, but my guess is that you've probably forgotten, so this might not even be reviewed. Here's what we're going to do today. We've been solving systems of equations, and your answers have looked kind of like this over here, with a parabola and a line going through it. The answers have been where the line intersects the parabola, right? Just like in the warm-up. Now we're going to do a system not of equations, but a system of inequalities. And when you have a system of inequalities, it's not just a point that is your answer anymore. Let's solve these and graph them to get started. To get y by itself, subtract 4x from both sides. So you get y. Do I flip the sign?
No.
Why not? Negative. Oh, I didn't divide? Okay. My bad. Plus 5. Good. Let's solve the other one too now. Hmm. Trying to solve for y. Mm-hmm. One more step. Divide by -3. Ah. Oh. Okay. Flip the sign. Cool. So we got two inequalities, not equations, inequalities. Why are they unequal? Because y is less than -4x plus 5. It's smaller than that side. And over here, y is bigger than x plus 18 over -3. They're not equal. Y is bigger. Okay. Let's graph these. So take your calculator, look at the graph. Goodness gracious. And the question is, how do you graph an inequality? Because it says equals. Press delete. So get rid of the equal sign. Press delete. And pick the correct one. Is it 1, 2, 3, 4, or 5? Is it 1? We're doing the first one, right? What was the first one? -4x plus 5? Uh-oh. Whoa. Whoa. Crazy. Okay. So can you interpret what this means? What does this mean? Mm-hmm. Kind of. The best way to say it is like this. The shaded graph represents every point that makes the equation true, or the inequality true. So say we have the point 0, 0, or the x value 0, I should say. Okay. If I plug in 0 on the graph, if I go sideways on the graph, let's see, right there, right? Okay, so let's put 0 in. So -4 times 0, 0, plus 5, 5. Right? So if I go to the x value of 0, over here I get 5, over here what do I get? What is y when x is 0? Look, follow the line. I'm going to try to come close and make my x value 0. Y is like 4.7. It's not quite on 5, is it? Can you see that? Can you see that? It's if it is 5, it's right at 5. Okay? So let me ask you this. Is 5 less than or equal to 5? Is 5 less than or equal to 5? So that's true. Right? True. Okay? Same thing with the point 0, 0. Right? If I just put 0 in for both of these, -4 times 0, 0, plus 5 is 5, right? Okay? If I put 0 in right here, I have 0 is less than or equal to 5. Is that true?
Yeah.
Yes. So any point in the blue makes this true. But what if I pick a point outside of that? Like, what do you want? 10. The point 10, 0. Okay, let's plug it in. What's negative 4 times 10? Negative 40 plus 5? Negative 35. Okay. And the y value right there is 0. So here's the statement. 0 is less than or equal to negative 35. Is that true? No. So that's why this point is not shaded in. All of these points are shaded in. All of these points make the statement true. All of those make it false. We tracking? Before, it was one point that made it true, or one line of points that made the equation true. Now, it's a whole side of the graph. And watch this too. You see what's the inequality again? Less than or equal to? Notice that the graph, the part that's shaded in is the part to the left or the part underneath the line, however you want to look at it. See that? See how the line slants this way? So underneath would be that, on top of the line would be over here. One more thing. I'm almost done, I promise. Is the line dotted or solid? Solid. What do you think that represents? Less than or equal to. So since there's a line underneath the inequality sign, the line is solid. All right, so that's your introduction to that. Let's graph the other line. What was the other line? Okay. Oh, you did it like that, huh? It's greater than, right? So wait, should we have a dotted or a solid line?
Dotted.
Dotted. Cool. Take a look. I already forgot. X plus 18 over negative 3. I can't. Computer, please help. Promise you. Control, divide, X, plus 18. Whew. Okay. I type it in right? X plus 18 over negative 3. Why can't I see my line? Why isn't my line dotted? There we go. Okay, so you might just have to deselect your line there. You might have to like hover over it or click on it, but you should be able to see a dotted line, and a large part of the graph is shaded in. Now let's talk about talk about sketching these now, okay? Talk about sketching. So back to the first graph, and what we want to do is we want to use the x and the y intercepts to draw our line. So the x intercept is at like 1.2. The y-intercept is almost 5. Draw a line and shade appropriately. Let's talk about shading real quick. What I just did is unacceptable. You cannot do it that way. Okay, so you cannot do a horizontal shade. Nope. You cannot do a vertical shade. What you need to do is you need to do a slanty shade, and then you need to go back and you need to color in each square completely. 100% perfect. Just kidding. As long as the right part of the graph is colored in, I'm perfectly happy. You said this is a misread and stuff. Turn it into art class. Okay, Okay, on this graph, we're going to have two graphs. It's kind of awkward, kind of weird. The other one, golly, this keyboard. Oh, well. What was the other one? It didn't even kind of, it's underneath here and right at the point there. You know, I'm not going to kill you for not having 100% completely perfect intersections. Ah, what's wrong with my line though? Exactly. Gotta be careful with these. Always something lurking in the shadows for you to forget. See, you forgot about me. Do you have anything to box? No. Now, we'll fill out the steps and then we'll do a problem. If we did these two separately, if this was a system of inequalities, the answer, pause, over here the answer was where they intersected, right?
Yeah.
Okay, the points where they intersected. Over here they don't intersect at a point. They intersect at a lot of points. So the answer would be, let me see if I can highlight it for you. You see where the answer would be? Everywhere that they cross.
So this is what you can do like a graph on the idea. Just isolate the line, just like go in here.
Okay, let's fill in these steps, which we pretty much just did. So what were some of the key ideas that we just had? First, we have to write each equation in y equals form. You could also call it standard form, get y by itself, isolate y. It's the area of the shaded region. Top there. Okay, then we took the first equation and we graphed it. Key point, how do you change the equal sign to an inequality sign? Delete, yep. To the correct inequality sign. Right, these aren't equations, they're inequalities. Press blank and graph the second equation the same way. Tab. We're going to put both graphs, both inequalities on the same graph page. And last but not least, sketch it. Unleash your inner artist. Sometimes it's going to be tough to find the intersection of the graphs. You might need to use zoom out or zoom fit. Let's talk about one more possibility real quick. You don't have to draw this. I just want you to look at it. What if we had something like that? The first graph was less than that, and the second graph was above it, and it was greater than or equal to that. They don't intersect. You can just use the empty set. So if that's the case, do not graph anything. Just use the empty set and say, if you want to, you can write no intersection. What that means is no numbers will ever make the inequality, the system of inequalities true. That means there is no answer to them. Okay, so this is an option. All right, let's go ahead and do one together, then I'll let you work. Let's solve both of these for y. First things first, subtract 9x from both sides. Divide both sides by 2. What do you like to do? Do you like to solve both and then graph both, or do you like to solve one, graph it, solve the other one, graph it? Solve them both? Okay, that's fine. You're getting ahead of me. Okay, subtract the x from both sides. Staying in descending order. Uh-oh. I bet someone forgot. Yeah, I'll continue to encourage you to just check them right before you start. Check that coefficient of y, and that'll tell you pretty much whether or not you're going to flip the sign. You can look at every one of these and know right away, you know, am I going to flip? Am I going to flip? Am I going to flip? Pretty much guarantee that on the EOC question when they ask you that you'll have to flip one of them. That's what they're going to try to assess or test whether or not you know to flip the sign. Okay. Next up, graph. Okay, what was that first one? Negative 9x plus 16. Negative 9x plus 6 over 2. Uh-oh. What did I forget? Yep, gotta change it to an inequality. Negative 9x plus 6 over 2. Okay, that's what my first one looks like. The other one is less than or equal to negative x plus 14 Now, be very careful. In fact, some of you are already making a mistake as you color. Only a tiny part of this answer is the solution. Only tiny part of this graph is the solution to the question. So first you can draw the lines. Both solid lines. And the other one is kind of like that. But only a tiny part is the darkest color. And the darkest color is their intersection which is the answer. Questions? All right, you only really have a couple problems on the back. Why don't you go ahead and work on those. If you get stuck, please do come see me.